Hello and welcome to the continuation of this stoichiometry. So we'll be talking about the idea of mole and molar mass before we go on with the actual stoichiometry. So remember, 1 mole is actually a unit of measurement, which is going to be a group count. So 1 mole is actually not just one molecule, but rather it's 1 mole is means 6.02 times 10 to the power of 23 molecules. So basically, you'll have more than not just billion, trillion, or quadrillion. It's more than quadrillion. No, okay, number of molecules. So what the 1 mole mass that you have is the mass of this total number of molecules. So for mole, we're actually just trying to simplify it by by trying to associate it as one molecule, but the real fact is it's not one molecule, but rather 1 mole or one specific count of that specific compound. So 1 mole will be the equivalent of your molar mass. So in a balanced equation, so from what the one that we've discussed a while ago, okay, 1 mole is going to be your molar mass. That would mean the mass is the molar mass of that, or the mass of that formula will be equivalent to 1 mole. Now, if you have number 2 here, this will be the equivalent of this will be the number of moles that is present in the reaction, not the actual number that you'll have. So if you'll have 2 moles, you'll have to multiply everything by 2. Okay, if you'll use 2 moles, and then that would be 2 mole of anything is going to be the molar mass multiplied by 2. Basically, how you solve the chemical formula is going to be based off the number of moles, and we are using the lowest number of mole possible. Now, another thing here is actually the chemical equation actually also tells you the ratio of how many reactant is needed for a specific reaction. So for example, for every 2 of H2, you can have 1 oxygen and you can have 2 dihydrogen oxide or water. So for 1 oxygen, you're going to need 2 H2, and you might be able to produce 2 dihydrogen 2 dihydrogen oxide compound. Or you can actually say it the same and vice versa from the product's perspective. So from dihydrogen oxide, to create dihydrogen oxide, you're going to need 2 hydrogen molecules and 1 oxygen molecule. So that's I mean 2 moles of oxygen and 2 moles of hydrogen gas. So that's a basic description of how it works. But since of course since the ratio is this way, you could actually sometimes say that for 2 molecules of hydrogen you'll have 1 molecule of oxygen. But for solving it in stoichiometry, you count it as moles. Okay, anyways, let's proceed to solving. So for this one, the 3.61 here is going to be your carbon monoxide. So to balance this equation, if you look at this, you have 1 carbon, 3 oxygen. Now the only way to balance this is, let's just make it 4 first before doing anything that is higher than 4. Okay, so since this is 3, we can make the number of oxygen first at least 4. That will be the minimum increase that we can have. So 2 times 1, your carbon becomes 1. 2 times 1, your oxygen becomes 1. 2 times 2, so that means your carbon is 2, your oxygen is 4 on the reactant side. To make it balance with one another, you have to multiply the product side by 2. So 2 times 1, your carbon becomes 1. 2 times 2, your oxygen becomes 4. Now you have a balanced chemical equation. A while ago, we've talked about the ratio of this compounds and how it might affect the your balancing, you're solving for stoichiometry. So, A and B. First one, you're being asked how much moles of carbon dioxide and how much mole of oxygen gas is there. So first, if you've noticed in this problem, you'll see that the ratio of carbon dioxide and carbon monoxide is the same. So instead of doing anything, you could actually say for every 3.6 moles of carbon monoxide, you'll have 3.6 moles of carbon dioxide. Why is that? So 3.6 moles of CO carbon monoxide is equivalent to 2 moles of carbon dioxide and 2 moles of carbon monoxide. If you notice, this is 2. Since this becomes 1, your final answer is going to be the same as your given because of the ratio, which is 1 to 1. Now, for your oxygen, 3.6 moles of carbon monoxide is going to be the one on top is going to be your oxygen, remember? So that will be 1 mole of oxygen and 2 moles of your carbon monoxide. So 3.6, cancel your mole of carbon monoxide. So 3.6 times 1 divided by 2 is going to be 1.8 moles of oxygen gas. So all you're doing is trying to apply the ratio on how it's going to affect the change, any change in the number of your gases. Since this is a balance equation, they most certainly would affect their number. Remember the law of conservation of mass. If there is any change here, okay, you bring out everything, but you need to follow the ratio based off of that chemical equation because of the law of conservation of mass. Now let's continue on. So for this one, limestone decomposed by heating it to quicklime or carbon and to quicklime and carbon dioxide. Calculate the number of grams of quicklime that can be produced from 0.5 kilograms of limestone. So let's try to write the equation first. So it's decomposition. So from limestone you create it's decomposed, there's heat because there's heating. So for you create quicklime, which is CaO plus carbon dioxide, CO2. Is this a balance equation? 1 carbon, 3 oxygen, 1 calcium. Okay, we have a balance equation. The ratio is 1, 1, 1. Remember a while ago, one of the things that we need to have is the mass of your compounds. So first, let's try to solve for the mass. So calcium is 1, your carbon is 1, your oxygen is 3. Okay, so since your calcium is going to be 40.8, your carbon is going to be 12.01, your oxygen is going to be 16.00. So, oh, sorry. So 40.08 plus 12.01 plus 16 times 3, your mass is going to be 100.09 grams per mole. Okay, so your mass for your quicklime is just going to be 40.8 plus 16. So 40.08 plus 16 is going to be 56. So this will be 56.08. So your 12.01 plus 32. This will be 44.01. This will be the grams per mole of the two other reactants. Anyways, now calculate the number of grams of quicklime that can be produced from 0.5 grams of limestone. So what this one is saying is the number of limestone that you have that is not based on the ratio of your formula is 0.50 kilograms, which is going to be 500 grams of limestone. So 500 grams of limestone, which is going to be CaCO3. Now to solve for this one, okay, you have to calculate the number of kilograms of limestone. First, since you already have the limestone's unit of molar mass, you can actually convert it to mole first. Okay, so first 500 grams, okay, times the ratio of the mole and molar mass. So 1 mole of CaCO3 is 100.09 grams. So that's the first solving that you have. One of the ways that you could actually solve is continuous solving. Now after this, what do you want to solve? You want to solve for the number of quicklime, which is this one. So what is the ratio of quicklime and your limestone? So this is 1:1. So since that's 1:1, just try 1 is for every 1 mole of quicklime, you have 1 mole of your limestone. So if you see, I replace it here to cancel this for this one, cancel the grams. So the next one is now you want to calculate the number of grams for quicklime. So after this, you convert the grams into mole, right? This becomes mole, from grams to mole. Now, from the mole of your limestone, you solve for the mole of your quicklime. Now, from the quicklime, you can actually solve for the mass. Now, the ratio of mass is for every 1 mole of quicklime, you have 56.08 grams of your 56.08 grams of your quicklime. So what do you do? 500 divided by 100.09 times 1 divided by 1, and then you multiply it by 56.08. So what you are left with is going to be 280.1478669 grams of your quicklime. So from that 500 grams, you'll have 200.1478 grams of your quicklime. Now, how do I check this if my idea is correct? So actually, you could actually check this by trying to solve for your carbon monoxide. So we'll just follow the same process. So 1 mole of your limestone, 0.09. So for every 1 mole of your carbon dioxide, you divide it by 1 mole of your limestone. And then you multiply it by your carbon monoxide's mass, 4.01, divided by 1 mole of carbon dioxide. And then, if you actually solve for this one, 500 divided by 101, and then you multiply it by the mass, you'll actually have a number that will be a complement to fulfill to complete a 500 grams of